So classify the following as being in row echelon form or reduced row echelon form, or sometimes it may be neither in row echelon form or nor reduced row echelon form. So let me add another matrix here. E given by 1, 2, minus 3, 4, 0, 2, 1, 1, 0, 0, 1, minus 3. I have F 1, 2, minus 1, 2, 0, 0, 0, 0, 0, 1, 2, minus 4. So the question is matrix A in row echelon form? Yes or no? And why? Can A be described as being in row echelon form? So A is true. You see, remember the case where we were describing the process of or the conditions to be satisfied by matrix of inversion form. We say that the first condition we gave, all 0 rows, if any, are at the bottom. So you remember, you don't force that condition if the matrix has no 0 row. We only take care of that condition when we see that the structure of the matrix given, there's a row that has all the elements as being 0. If there's no row that has everything to be 0, then that part really doesn't really matter. You go to the other part, which involves leading ones. So the first thing is that all these rows of matrix A are non-zero, because at least you can see that in each row, there's a value that is not 0. So identify the first non-zero entries in each rows. And we see clearly that in each row, the first non-zero entry is 1. And if you are to compare the ones in these 3 rows, if you go to the second row, the 1 is to the right of the 1 in the first row, which agrees with the second condition. And then also when you check the 1 in the third row, is to the right of all ones of rows above that element 1. And since all the first non-zero elements in each of the 3 rows is 1, and that second property is satisfied, this matrix is said to be in row echelon form. Does it qualify to be in reduced row echelon form? Why? Like when we go to leading one in the, does leading one in the first row have a problem? The first leading one in row 1, does it have a problem? Is there a problem with that leading one in terms of the definition of reduced echelon form? Remember, reduced echelon form, the first condition is that ensure that the matrix already is in row echelon form. Then go to the places where you have leading ones and check that where there's leading one, everything in that column, that's the only non-zero element. Other positions will be zero. So my question is the leading one in the first row have any problem with that condition? There's no problem with that because this is the only element, one non-zero element, other positions are zero. So there's no problem with respect to the first leading one. But when you go to row two, is it true that the leading one is the only non-zero element in that column? No, there are two, okay? And when you go to this other leading one, is it the only non-zero element in that column? Yes or no? No, there's a negative one. So this matrix is not in reduced row echelon form. Okay, if you are to change it into row reduced row echelon form, what adjustments should be done? If you are to change it in, what changes should happen for it to be in reduced echelon form? What adjustments? Which position? Which position should be zero? Which position should be zero? And then column 3. Yeah. So if this was zero, if this position was given by zero, and this position was given by zero, then this matrix has been reduced to echelon form. Remember, this last one doesn't matter. What only matters is that once we have checked that the matrix is in row echelon form, then to confirm further that the given matrix in reduced echelon form, you just ensure that the columns which have leading ones, one is the only non-zero element. That's the only confirmation. So if this was zero, then this would be in reduced echelon form. But that was not the case. B, yes or no? Is it in a row echelon form? Yes, because you see, this is 1, this is 1, and this matrix has a row that has all values to be 0, which happens to be in the last row. So as per the first condition, if there's a row that has all elements to be zeros, it has been placed at the bottom. So, and this first row that has leading ones, you see that the one in the second row is to the right of one in the top row, which is the condition given in 2. So this is true that this is in row echelon form. Is it also yes or no? Yeah. So this also in reduced row echelon form. Reduced row echelon form because it has already satisfied all the conditions for being in row echelon form. And each column that has leading one, every position is occupied by 0. So you don't worry about this third column because this doesn't have a leading one. See? Yes. So these are in reduced, this is in row echelon form. So this is 1, this is 1, this is 1, this is 1. So there's no row that has all the elements zeros, and leading ones from second row up to the last row, there can always be taken to being on the right with respect to what leading one on the top rows. Is it in reduced echelon form? No, because for instance, you see there's a 2 here, there's 3, -1, there's 4, -2, 3. So not in reduced row echelon form. Then D, row echelon form or not row echelon form? Is it in row echelon form? Yeah, you see this is 1, this is 1, this is 1, and there's a 0 row that is at the bottom. And with all these zeros, all these leading ones, when you go to a lower row, that leading one will always be referred to as being to the right of the leading one on the top row. So this is in row echelon form. Is it also in reduced echelon form? Yeah, it's also in reduced echelon form because once it has satisfied all the conditions for row echelon form, you see that every column that has a leading one, all other elements are zeros. So you can clearly see them. So it's also in reduced row echelon form. Then E, is it in row echelon form? What makes it to miss that property? Yes, the leading non-zero element in row 2 is 2, which shouldn't be the case. Remember, for any non-zero row, for a row echelon form matrix, that element must always be 1, not 2. So that is what messes this up. So this is not in row echelon form. Is it in reduced row echelon form? No. So remember, once it fails the test for row echelon form, then obviously the other test fails. So this is not in reduced row echelon form. Remember, for you to reach the condition for reduced echelon form, you must have satisfied the echelon form condition. If you didn't satisfy that condition, then obviously it can't be in row echelon form. If row echelon form or non-row echelon form. Why? Yes. So you see this matrix F has a 0 row, and this 0 row is not placed at the bottom. So this is what makes this not to be in row echelon form. This 0 row should have been at the bottom. So you see this is a non-zero row, but it's placed below the 0 row. So that's the problem with this. So this is not in row echelon form. So if this was above and this was below, then it should be important. So once that one fails, also this matrix cannot be reduced row echelon form. So next time we meet, we will be discussing methods of converting non-row echelon form matrices into row echelon form matrices, and also how to extend from row echelon form to reduced row echelon form. So next. So we'll be discussing methods of solving linear systems, which involves conversion from non-row echelon form to row echelon form. And the first method will be Gaussian elimination. Number two will be Gauss-Jordan elimination method. So being a senior candidate, being in a senior class, master's class, you don't have to wait up to the time we'll be discussing this. You can always use the handout, which I'll give, or the lecture videos that are provided to see how the method works. But we'll also explain when we meet next. So have a good evening.